And here's our flipbook. So this is going to be kind of the end of the road for our sphere source. Anyway, soon basically next chapter, we're going to do a particle-based source. But there are still a few more things to sort out before we do. Number one, it's pretty dark in spots, so just as a little extra thing, let's take these distant lights and make them have like an intensity of 2. Just so we can see better. You know, we will again control the lighting more explicitly later, but right now we're just kind of figuring out the shape and stuff, and I don't want to miss anything. So that's the first thing. Second thing is, I mean, this is way below the ground plane. You know, I mean, this is just sitting way down there. We don't have a ground plane. We never set one up. So let's set one up. Let's go into .NET. And we don't even need to actually make... Why is that there? I never actually hooked that up. You don't really need to, but it just feels better. Anyway, we never actually put one in. You can do it right here under boundary conditions. Treat Y as closed below. And then right now, by default, it's right there at the ground plane. I like to take the voxel size and then say... Well, put it in here first. So paste relative references... and then say negative that. So basically, I just want one more voxel below the surface, or below the ground rather. So let's see what that looks like. So there you go. See, now it's flat along the ground. I like the one extra voxel. As we talked about, I think in the previous lesson, it allows you to basically have the smoke rest on the ground. If you have the actual boundary be on the ground, sometimes you can kind of see a little bit of a gap, especially if you're low to the ground the way we are right now. So anyway, so already that kind of looks pretty cool. We have more of a mushroom earlier on, you know, compared to what we had here. So it's frame 41. So we used to look like this, where it was sitting on the ground. Now it's literally been pushed up from the ground. So that's good. I mean, you know, we needed a ground. Either way, we just simply can't have it going below the ground. Now the final thing is really interesting. Look at the shape that we have on here. Look at all these squared things everywhere. There's these square kind of like corners, these divots, corners, and this is clearly a square thing. Maybe you can guess what it is, but if you can't, what's happening is it's this. It's this, the sparse maximums, essentially, basically the extents of our sparse sim. You know, it's always trying to keep this as close to the sim as it can. You know, it's resizing it based off of, if we go to the solver and we click on the advanced and we see padding, it's looking to see where density and or flame is, and every frame it will make sure that if it's within 0.3, it'll, you know, kick it out another tile's worth. So that's what these cubes are. These are tiles, which are big collections of voxels. So it'll just keep adding, as you can see, more tiles on as is appropriate. And the more tiles we have, the slower it takes to sim, the more memory we take up. So we want to have it not do it. We want to be as aggressive as possible. So we want the padding to be as low as possible. However, before, when we actually sourced our flame and temperature in, we were able to say enlarge fields to contain sources to ensure that bringing this in automatically, immediately popped that to be able to encompass that. But that's not the only way that we are kind of sourcing into this. The divergence, though, the divergence is causing the solver to make the stuff expand. So we're not sourcing things into these voxels, but the solver is putting them there. The solver, however, does not take that into consideration when doing the resize. Perhaps it should, but it doesn't. So long story short, what you're seeing are artifacts of it coming up against these. So these are the divots and things that are being carved out of it. And again, you can really see it here. Like, yeah, or look from above, you can really see it. So I think you get it. So obviously, we need to increase the padding. If we double it, that might get you somewhere. It probably won't be enough. I can already start to see them forming here, so that's not enough. You could try to go to like a little bit more than double there. Still seeing them. Still fairly pronounced. I mean, the reason why we're seeing it even after raising it so much is that this is in world space units. Look how big this sim is. I mean, it's like 10 to 15 units across. So just going from like 0.3 to 0.6, the whole thing is like tens of meters across. This is very closely related to the scale of what we're doing. So we apparently need to do more. So now we can start to see it's clean. So unfortunately, you know, it sticks out a little bit further than it might have been otherwise. We're actually still seeing them though. At this point, you can wonder, you know, we're going to break up this shape later on using some techniques, but it's still better to start from a place of it being right. You might disagree. You might argue that it's better to start from a place from it being a little bit faster, maybe, or taking up a little less memory. But I would still say, let's try to get it to be right. Because we have one more trick up our sleeves. Remember earlier we were talking about the substeps? We were talking about it in connection with normalizing the sources with regards to divergence and things. We often do want to increase max substeps, almost pretty much every time. When you have only one substep, as is by default, sure, it's fast. But the complexity of motion that you get can only be so interesting, because if you only have one substep, meaning really no actual subframes between frames, then any given point in this sim can only go in a straight line from this frame to the next, because the velocities are all straight lines. So it can only really go in a straight line. Once you start adding more substeps in, something could go from here to here, or let's say from here to here, and then from here to here within one frame. Now, of course, the end result is that it moved from here to here. But when lots of things are moving in that cyclical manner, you will see it kind of rotating, and you can feel more complexity. I mean, you could just imagine in general that, of course, more substeps tends to mean it's a better solve. If we could have 1 million substeps, we would do it. But we can do 2, though, at least. The reason why I bring all this up is this whole padding thing, where it's checking to see if it needs to extend it more, is happening per substep. So we want to increase the substeps anyway, just to make our sim look good. And that will actually help us with the padding as well. So we may not need to go any higher than 3 in order for all of those little artifacts to go away. And so instead of bumping this to 6 or whatever, I can see we don't have any of those artifacts anymore. Or if we do, we might have the slightest little ones. But I'm not even sure if that is one. In any case, I don't feel like finding out either. Overall, I don't really see squared shapes. I mean, I see this, but that's really just because of the way the voxels look in OpenGL. But as actual features go, and not just, you know, all the little voxel cross sections, which is not the same thing, I'd say this looks good. In fact, this looks like a little mushroom. And I don't mean like a mushroom cloud like a nuclear explosion. This looks like the little white mushrooms that you see in like grocery stores. Anyway, I can't remember what they're called. But there you go. So we've got multiple substeps. We've got it not smashing into the walls anymore. And we made some lights a little bit brighter. So now let's actually move on to the main event, which is do our particle-based sourcing.